All right, we're once again going to be talking about segment bisectors. Segment bisectors. All right. Our question here is, how do I use segment bisectors to find segment lengths in problems involving variables? We've already talked again about what's a segment bisector, so I have to go over that again. So let's just jump straight into our example. Okay, here we're going to find AB, where M is the segment bisector of AB. Now let's take a look at our diagram here. So there's a nice big long line here. There's A, there's B, here's M in the middle. These two segments are the same length. We're going to have a couple of expressions here. We have 11x minus 17 for AM, and we have 2x plus 10 for AB. So we've got our statements and our reasons. And this is going to be very similar to when we did segment addition problems. We were finding the length. It's going to start out just by solving for x first. So let's start with that. So we start out by saying that AM equals MB. And that's just the definition of bisector. Okay, the bisector cuts that segment into two equal-sized pieces so the two distances are equal. So next we'll do our substitution. So we've got 11x minus 17 equals 2x plus 10, and that's just substitution. And we'll say from star, and I'll just put a little star up here. All right, that's where we got those from. Okay, next, we're going to want to get all our variables on one side. Let's see, I've got 2x here, 11x here. I'll take 2x away from both sides. That's going to leave us with 9x here, and just this positive 10 over here. And we had to take away 2x, so that was the subtraction property. All right. Okay, next, let's see, we want to have, we don't want to have any constants over here because we want all the constants on the other side. So we're going to take this negative 17 away by adding 17 to both sides. That's just going to leave the 9x over here, and 10 plus 17 is 27. And here we use the addition property, of course, of equality, but we're getting lazy here. Next, I got 9x equals 27, so a single x, well, to get to that single x, we have to divide by 9, so we have to divide both sides by 9. 27 divided by 9 is 3. So now we've found x. And we used, in this last step, the division property of equality. All right, this is kind of the midway through the problem here. We solved for x. Now we're going to go back and find AB. Now keep in mind, we could do the same thing to find AM or MB. We just happen to be finding AB this time. So So let's go take a look here. Well, let's see. We know that AM plus MB equals AB, and that's just segment addition. Okay. So now we'll substitute our expressions in there. So let's see. We have 11x minus 17 plus 2x plus 10 equals AB, and that's again substitution from our star up there, same place we substituted from before. Now I'll have to combine some like terms. Let's see, 11x and 2x, well that's 13x. And negative 17 and positive 10, that's a negative 7. So, and that is, let's see, that would be combine like terms. Combine like terms. Next, well, if we're going to find out what this whole expression works out to, we need to know what x is. But we do know what x is. X is 3. I'm going to put a little double star up here, and we're going to call it substitution, this time from double star. All right. So then we have 13 times 3 is 39, minus 7 is 32, equals AB. And that's simply simplify. So we simplify. So we found AB. All right. I'm going to toss on the side here as a little extra, a check. Okay. We're going to find AM. AM equals 11x minus 17. And we've got x equals, well, this is, by the way, given in diagram. 11 times 3 minus 17. And that's just substitution. Wait, I missed something there. Substitute from double star. AM equals 33 minus 17. Okay. And that's just simplify. All right. And then we've got AM is 16, which again we just simplified. Okay. Our little note here is that checks out. AM is half of AB. Check. All right. If we had gotten anything else, then that would have been a problem, because that would mean that M was not the segment bisector or the midpoint in this case. Okay. All righty. So again, in this case, we found the distance from A to M. Our original goal was to find the distance from A to B. To do that, we had to figure out what x was. So this starts out just like one of the other problems we've already done, where we start out with the two parts are the same size, which is the definition of bisector. Then we substitute our two expressions from the original diagram. And we just basically solved this two-step equation, this equation with variables on both sides by gathering all our variables on one side, all our constants on the other, and then dividing by the coefficient of x. We've listed here the different properties we use. Of course, every equation will be different. Then, once we knew what x was, we just set ourselves up with this segment addition. Now, if this had been just find AM in the first place, we wouldn't have had to set up that segment addition thing. We would have just known that AM was 11x minus 17. But we didn't have a single expression for AB. We had to put AM and MB together using the segment addition postulate. Then we did our substitution, again, from the diagram, from the original star there. We just replaced AM and MB with our two expressions. We then combine like terms, just to simplify that to a single expression. And then we we substitute 3 for x. And then once we did that, we simplified and found that AB was 32. So in general, this process will be the same for every problem, but exactly how you solve the equations and how you evaluate the expressions will be a little bit different each time.